Good morning, everybody, and thanks for being here this morning. What we are going to do in the next 20 minutes or so is to address the issue of the Mediterranean diet from a pharma-nutritional viewpoint. What we want to do is to elucidate the role of some bioactive nutrients or micronutrients present and abundant in the Mediterranean diet from a pharma-nutritional viewpoint. Why do we do pharma-nutrition? Why do we study these nutrients in the lab? One of the issues we need to address is what it's called the wish bias. Wish bias is that we all want to hear things that we want to hear. So just to explain these things better, several times people and even researchers want to hear things that they really like, that are really appealing to them. And this becomes evident in epidemiology. This is an example. These are great researchers. First of all, are great researchers. I know them all. How outstanding scientists. Many of them carried out the PREDIMED study, which is a very famous intervention study, which was the first one actually to date, is the only one that demonstrated the clinically demonstrated the beneficial effects of the Mediterranean diet. And among the various results was this one. Compared to non-consumers, subjects who consumed nuts more than 3 servings per week had a 30, which was the 32% of the cohort investigated, had a 39% lower mortality risk. This is biologically implausible. It's basically it's impossible that just by eating nuts 3 or more times per week you have a 39% lower mortality risk. There's something wrong with statistics. But we all want to hear this. Most of the data we know about nutrition come from epidemiology. Epidemiology is a very important field, an extremely important field, but it's very different from clinical trials. The data we obtain from epidemiology are very different from the data we obtain from clinical trials. We need to be very careful with epidemiology. So epidemiology, again, it's fundamental, super important. It provides us with the basis with which we should trigger further investigation, stimulate further investigation. Why do we say that epidemiology has limits? Well, for several reasons. When we want to know what people eat, what do is that we administer food frequency questionnaires. So basically, we distribute a questionnaire and we ask people, what did you eat yesterday or what did you eat last week? And this, of course, has limits. What I'm going to show is the US nutrition surveillance, which was called the NANES, National Health and Nutrition Examination Survey. This is the largest and biggest and most important dietary survey ever carried out. What it showed is that most people lie when they fill out the questionnaire. In this case, if you analyze the data of the names of this very important and very large survey, 67% of women and 58% of men had caloric intakes that were incompatible with their lives. So it's again, we need to be very careful when we examine these questionnaires, and then, because then we draw conclusions that might not be applicable to the general population or to patients, for example. There are several examples that can be of fallacies that can be found in the internet. For example, if we do not have enough engineers, well, we should just eat more mozzarella. The rate of consumption of mozzarella parallels in civil engineering doctorate award. But do not eat too much, because if you eat too much cheese, you might become entangled in your bed sheets. The percentage of people who die because they become tangled in the bed sheets parallels, once again, closely parallels those who eat cheese. This we can make associations that go up and down. For example, this is the number of films that Nicolas Cage appeared in, which again closely mirrors the number of people who drowned by falling into a pool. You see that more films by Nicolas Cage, more people drowning, fewer films, fewer people drowning, and so forth. Final one, it can become even more complicated. The age of Miss American, well, it closely recalls people who were murdered by steam, hot vapors, or hot objects. You see again, up and down, up and down. So why are we showing this? Because in this case, of course, we do not go into the lab, or we do not carry out further experiments to show anything. This does not make sense. This is just a statistically implausible association, and it's just by chance that we see this data. But the same line of reasoning applies to food and health. We can find the same association between, I don't know, tomato consumption and stomach cancer, between green tea drinking and lung cancer, between olive oil and cardiovascular disease. So in the latter case, that makes sense, and we go to the lab. But again, do not draw conclusions based just on epidemiological data. It's also very important to underline that food is very different from drugs. So the effects we see with food, supplementation with food, dietary interventions are very, very small as compared with those that we see after pharmacological intervention. There are several differences between the two. Food is usually used for energy or for nutrition, while drugs, you only use them to treat disease. Drugs, you use them for a very short period of time, or the shortest possible period of time. They must have an immediate effect, while food, you use food throughout your life. And so the benefits, you might reap the benefits many years after you start a dietary regimen. Everyone eats. Drugs are targeted to a very specific subset of population. The first thing we want of food is of it to be safe, while drugs are never safe. We always need to balance benefit with risk. And also, drugs are the only item that you cannot choose. The physician prescribes them, while you can choose different foods. You can choose your diet, you can choose different kinds of food, or different types of food, whatever. So what we expect from food is called the metabolic tune-up. It's like taking a car to a mechanic. If the car breaks, you go to a hospital. Okay, it's the equivalent of going to a hospital. But if you take good care of your car by fixing a little bit the pressure of your tires, by checking with the oil, and so forth, you will never notice it. You still drive the same car, but your car will perform better, and its life, you prolong the life of your car, and so you will, let's say, have fewer, decrease the chance of going to the mechanic, to the hospital in a way. Okay. Again, this is probably the final example we see. I'm going to show about the difference between intervention, in this case with foods, and epidemiological study. It's the classic case of beta-carotene. If you look at the upper part, this is a meta-analysis. People who eat more beta-carotene are protected from cancer. The bottom part of the graph, when we give people beta-carotene, basically we kill them. So giving beta-carotene to people increases mortality, while eating beta-carotene from food decreases mortality. Why is that? We probably don't know. Maybe beta-carotene is just a marker of something else, or maybe beta-carotene with food has different effects than that we take with capsules. We still don't know. There are several theories about it, but make sure that all the data you read that come from epidemiological study, well, taken, with some caution. And why is it so difficult to prove the effects of food? Well, one of the things that we need to keep in mind is that most trials are carried out in healthy subjects. Most trials with foods require interventions on healthy subjects and not on patients. Again, this is very different from drugs. It would be a bit like giving penicillin to someone who has not an infection. What do you see? Well, basically nothing. You need a patient with an infection to see an effect of an antibiotic. But this is ethically very, very difficult to do with foods. And this is what the 2 times Nobel Prize Linus Pauling called orthomolecular medicine, meaning modulate the health or the health status of your body, your physiology, by modulating the levels or contribution of molecules that you already have. So no pharmacological intervention, but intervention with molecules, vitamins, minerals, polyphenols, whatever, that you find in food that are already present. Most of them are already present in your body. Just by modulating the levels, the concentrations, you might see an effect. Also, the problem we have when we study food or when we study molecules derived from foods is that nutraceuticals, supplements, whatever, are added to what is called already a top pharma intervention. This is a classical example of omega-3 fatty acids in cardiovascular patients. They're already added to statin therapy. Very difficult to see an effect when patients are already optimally treated, and you cannot stop treatment just to show an effect of your food component. You must ethically carry out the best possible pharmacological treatment. Then you add some food components on top of it, very difficult to find an effect. Final problem is the scarcity of biomarkers. This is basically the holy grail. This is what people are looking for, the best biomarkers of food effect or a food component effect. While we do not have many biomarkers, it's in a way, in 2017, it's like studying hypotensive drugs without being able to measure blood pressure. You give them the drug, and then what? You cannot measure blood pressure before, cannot measure blood pressure after. And so when we study, again, some vitamins or some minerals or some foods or some concentrates, it's very difficult to measure something before and something after. Remember, the effects must be really limited. The effects of food and food components must be limited. So in this respect, we are building our own roads. The research is still lagging a bit behind. Now, these are just some examples pertaining to the Mediterranean diet of how we can perform pharmaconutritional research to suggest an effect of some food components. This was a project called Local Food Nutraceuticals, supported by the European Community, and we went to three areas, which were southern Italy, Crete, and southern Spain, where food or diets are still really traditional. So people go out in the fields, pick their own vegetables, pick their own wild herbs. What we did is we did first an ethnobotanical field work in which we asked people what they ate, whether they used these herbs for treatment or for food. Then we extract the herbs and we did some pharmacological assays. In particular, or one of the examples I want to show is that we measured the effect of some extracts on nitric oxide production by endothelial cells. So these are endothelial cells stimulated, see the yellow bar. They produce even more nitric oxide when they add it with Cynara cardunculus, which is wild artichoke, and Thymus pulejoides, which is thyme. So this is an in vitro experiment that shows how an extract of two extracts of wild plants increase nitric oxide production and have vasorelaxation properties, potential. In fact, in vitro experiments do not really prove anything. It's a bit like epidemiology. They strongly suggest. Then you need to carry out further experiments. In this area, we did an in vivo experiment with Cynara cardunculus, in which we fed rats 10 milligrams of polyphenols per kilogram during 5 days of Cynara cardunculus extract, and then we measured vasorelaxation. You see the black line are the young rats, the red one are the old rats. They do not vasorelax as well as the young ones, but when you give them wild artichoke, Cynara cardunculus, you recover about 50% of vasorelaxation. We will never go back to the original condition of young rats, but you still have an interesting effect. And we also saw an increase in prostacyclin production by the same aortas. Now we go even deeper into our investigation. So from epidemiology, that again cannot prove anything but suggests effects, and it's the most important starting point. We go down to nutrigenomics, and we will do an example based on a typical product of the Mediterranean diet, which is olive oil. The most important component of olive oil is this phenol called hydroxytyrosol. which is the only phenol with an EFSA-approved health claim. So it's important for people to understand that research on hydroxytyrosol is very much advanced. Several years of data, or published data, show that hydroxytyrosol has biological effects. And now it's going to become a bit complicated. We wanted to see the effects of hydroxytyrosol at the genetic level. So nutrigenomics is the science, is the branch of science that investigates the effects of food on your genomic background. This is a paper we published in 2014, in which we fed nutritionally relevant amounts of hydroxytyrosol, and we wanted to see its nutrigenomic effects in the adipose tissue, which is a very relevant metabolically active tissue. Well, we saw a decrease in plasma cholesterol, also a decrease in plasma leptin. The consequences of this decrease are still unknown, are still unclear. But then we also saw the nutrigenomic effect. These are all the genes that relate one to each other, and most of the genes that were modified by hydroxytyrosol pertain to the redox function of the adipose tissue. You see the superoxide dismutase, glutathione transferase. Phase 2 enzymes and redox cycle can be modified by hydroxytyrosol at the genetic level. This is a list of genes that were modified by feeding hydroxytyrosol. Again, most of the genes pertain to metabolic processes, transport, glutathione network, which means redox status, oxidation reduction processes, so forth. So the metabolism of the adipose tissue can be modified by hydroxytyrosol at the genetic level. And this is a Venn diagram that summarizes our findings. Glutathione peroxidase, glutathione transferase, oxidoreductase. So phase 2 enzymes and redox cycle can be positively affected by feeding hydroxytyrosol. We can go even deeper, and we can study proteomics. So food and the food components do not just modify your genes, can even modify the expression of proteins. So through very sophisticated techniques, we were able to evaluate the protein profile of the adipose tissue and the liver following hydroxytyrosol supplementation. You do not need to read all the data, but some of these proteins were upregulated, for example, caveolin or carbonic anhydrase. Some other ones were downregulated in the adipose tissue and in the liver. Again, the biological significance of these modifications is not entirely clear, but the bottom line, the message is that we are able, from epidemiological data, to go down to physiology, biology, and then even deeper into nutrigenomics and even deeper into proteomics. So just to conclude, some people think it's very easy to study diets in humans, but in truth, it's quite difficult. Food and food components are not drugs. The effects are really, really small, and some ethical hurdles should be overcome before we go into deeper investigation of foods in humans. However, the field is rapidly moving. We are looking for new biomarkers. We are looking for new interventions. We are looking for solid science to prove or disprove the effects of food components on the metabolism, on cellular metabolism, and on health. And this will advance the field when we combine clinical trials, whenever it's possible, molecular study, pharmaconutritional studies, to prove or to shed light on the effects of some particular food and food components. I would like to thank you for your attention. Get in touch with me if you need further clarification, and thank you again for organizing this important conference.